let's welcome Andrea Magnorsky.
Charged? No, that's a joke, but I would say chest. We say charged because I couldn't understand what I was with a few Polish friends, and I was trying to find a really difficult to pronounce word, and one of them suggested charged, which apparently I still pronounce badly. Anyway, digressions. My name is Andrea Magnorsky, and I am the founder, the co-founder of BatCat Games, Digital Furnace Games, which is both actually complicated terms for saying the same game company. And we develop a game called Onikira. I'm also one of the founders of GameCraft Foundation, which is a foundation, a not-for-profit that we do game jams everywhere, particularly in Europe. Game jams are like hackathons, but for games. So if you're here, you probably are interested in games, then you should go and make one. Yay. You can go to a GameCraft or whatever else. It's really fun to make a game. So yes, our game is called Onikira, as I was saying. It's available on Steam Early Access. What that means is basically you're buying a game that's not finished. So if you don't want to do that, you can buy the game now so that you help us finish the game. And also you help us with feedback and stuff. Basically it's available now since the 14th of November. What is amazing about this, and why I'm telling you this, is because we have over 20,000 players. So all of the things that I'm going to talk to you about today are stuff that we're doing for the game. So it's not like magical fairy dust that we think about. It's something that we're doing, and 20,000 people use the result of this. So I thought that was kind of cool, and our people maybe too, I don't know. The thing is, so this talk is called The Tools That Shape Us. And that was the title. That's why you came here, remember, when you were walking? So the reason why I was talking about tools is because everything that we, as developers, the way we use tools and the tools we choose shape our thinking. So if you choose to use F#, C#, PHP, monkeys, whatever, brain, fuck, that's how you shape your thinking, right? Is it on now? Okay. Oh, look at this. Oh, well. Where was I? Oh, yeah, tools shape our thinking. So basically, I'm showing you here these tools because I think they are, they help you think easier. They help you solve the problem faster because you are thinking that way. But the thing is, like, one of the first tools that we have as developers is our language, right? And even when you kind of meta on that, you kind of start thinking about what paradigm is the right one. And not so long ago, I was in a talk, and someone mentioned this paper called Out of the Tar Pit, right? And there's a picture that is a tar pit. I didn't find any better picture that was for non-commercial, so I'm sorry that it's ugly. This paper, actually, the picture is quite fitting because this paper talks about complexity and the sources of those complexities. And I mean, I'm sure you all had this problem that you're working on something, you start, everything's good, you go to work happy, and everything's great. As the time goes on, suddenly, one day you wake up and you wake up at 5 in the morning or whatever time that is too early thinking, because you have some problem, and it's hard to fix because it's a mess of complexity. So this paper analyzes the source of that complexity, which could be coming from state and its interaction, the fact that you have a lot of state going around, flow of control, which means basically how the data moves around and what changes it, and code volume. Now, of course, I'm summarizing a paper that is quite long into 3 bullet points, which is obviously not complete. So I suggest you go and, if you're interested in the sources of complexity, you should go check out this paper. Because otherwise you end up like this cat. Like, because complexity is very painful, and we don't want to have to deal with it. Basically, the paper kind of winds up with this one sentence. that making or writing something that looks or that is simple, it is actually quite hard. And what I found is that you wind up getting to something simple after a good iteration. So, Anyway, this paper basically proposes that functional programming helps you write simpler code. And this is why I started looking at functional programming more seriously. I've been hearing about it a lot, but then this is what made me think, okay, I really have to go and try this thing, because it just sounds too good to be true. And so we tried F#. So the thing is, I'm a C# dev for a good few years. I don't really want to think how many, because it scares me. One obviously F# is developed initially by Microsoft, but now it's an open source project that runs in all platforms, runs particularly well on Macs. It's production in Linux for someone that was asking in some other talk. Definitely runs on .NET, and the interop is amazing. It has a beautiful type system. Any fans of OCaml here? One, okay. You will be very happy with that, because F# is very OCamlish. And the best thing about it is that particularly for statically checked languages, you find that generally they are a little bit scary to get started on. And I like to call the F# learning curve divine learning curve. And some people look at me as if I had like 50 eyes, I was dressed like a monkey, it's like divine. What are you talking about? What I'm talking about is that even though the first time you try F# with something like perhaps the F# cones, those little exercises you can do, you're going to go like, if you come from a Java or C# or maybe even Ruby, you go try and go like, I don't know what this, you have to think about what you're doing, flip tables. But the thing is, you in 2 days of doing a few hours, you'll actually get quite comfortable, getting around the compiler. And then the thing is, like, you can do these little incremental steps on learning functional without having to kind of go and learn a monet just to print hello world, which is sadly what happens when you try to learn Haskell. Haskell is a beautiful language, but it can be quite daunting to try to do something, to actually finish something, at least in my experience. That's all I have. So, I told you how awesome F# is. Might as well show you some, right? So in here, we have a list comprehension. The thing is, I'm showing you this. And have you ever seen F#? Yes. Everybody's seen F#? No. Okay, so... No. What? I know. So some of you, yes, some of you know. I got this. So, I'm sure that the ones of you that didn't see any F# before can read this and actually more or less guess what it's going to do, and that's a good thing, right? This doesn't happen when you read Perl. At least never happened to me, right? So what we have here is a list comprehension. We have function composition here. We have some more function composition here. We have bindings. So here we're binding this function that has a parameter. It infers the type. For those of you in Haskell, this is Handley-Miller. Otherwise, it means that you can just do very nice type inference. You can define types. So this is a record definition. Again, one line. The language is quite concise. Is there any questions about this? Anything great? Do you see something go like, oh my God, what is that? No? Anything like that? I'll take that as no. Okay, next time I'm going to ask you difficult questions. So, yeah, you might be wondering why I should... Okay, so I'm trying to show you the language and say, okay, this is what we have. But how do we use it in a game? Right? So, basically, the way we use this in a game is we have an editor like this, this is called duality. It's very similar to Unity, if you've ever done anything like that. And basically, you have a scene with game objects. So anything that is inside the scene, you'll have it in the scene view. So these ones are games objects. And we have components, which is basically where everything runs. The rest is just data. I'm abstracting just to not stay there forever and ever, right? So basically, we can write scripts in C# or F#. For C#, we use Roslyn, and for F#, we use F# compiler services. So what we write is little scripts that are maybe 200-300 lines long. So that would be a little bit too long. A little book, 300 pages. So what we do is in those little scripts, we have to interrupt a lot with very dirty code from C#. So pattern matching seems quite natural. This is a pattern match, okay? So in here, we are trying to write the Fibonacci. This is a nice function that is recursive. And the n is an int. It's inferred by this. We're matching if it's 0, return 0. If it's 1, return 1. Anything else, this underscore will call recursively, and it will calculate it nicely. Again, simple, concise. So that's nice. How do we use it in our game? Oh, okay. So in here we have to unlock an achievement. So in here we say we pass a game object, and we have what is the achievement. When we're doing this part, the game object.get component, we're talking to a C# API, and we're getting that back. Because it's C#, it can be null. And so if it's null, we don't throw exceptions in the game, because otherwise the game will never run. We'll just kind of fail silently when something fails and hope that everything's fine. It's not totally a lie, actually. But if we do find something, then we can do if the character is not on the ground, then unlock the achievement, and then we say, get rid of this game object. And that's cool. And this means that, so what you're trying to do here is that you're unlocking an achievement for something that happens when you're jumping. Perhaps the first kill you have in the game. Perhaps something else, right? So you all played a game in your life. Yes. Good. Okay, so just checking. Hey, maybe someone lived in a bubble for a few years. So this sort of pattern match is this is different scripts. Okay, I'm just trying to give you an idea of how we can use it. Okay, so in here we're receiving a message, which is actually just a type that has so different messages have different things. But in general, you just have like some sort of string message by default. This little thing just checks if this message is of type actor died message, then you bind it to this name, died message, and you unlock an achievement. And you say, oh, it's an airplane. So it was, after all, that you unlocked the achievement when you're flying. Yay! Yay! Oh. Hey, there you go. Hey. Cool. Okay, someone is awake. So that's kind of cool. I mean, this is game code that is live in the game, that is here paused for you to play if you want to, maybe. So that's pattern matching. So what you're doing when you're pattern matching is basically matching to a data shape, right? Are you okay with pattern matching? I'm going to assume yes, because we're in Lambda days. But I never know. Better safe than sorry. So active patterns is a thing that basically, the definition of it is that you're able to name the expression. So in here, we're matching on an expression. And that's all well and good. However, sometimes you need to have slightly more complex expressions, or you need to combine expressions, so you can name them. This is a nice pattern, see the way, more complex patterns. So
I got a question about this code earlier. This here, it's because it's quite nice code apart from this dispose later, because is some interaction with C# runtime?
Well, actually, this is specific to the game engine that I'm using, which means that what you're going to do is you want that once for this script component, the game object on it, you're going to dispose the frame after you've run this. So you basically, that method, all it does is put this game object in a collection that will be disposed on the next frame. But the ugliness comes from C#, or ugliness. Basically, you have no choice. There are better ways to do this, and hopefully we'll get to writing an FRP wrapper around this. But the state is real. Okay? Does that answer your question?
Yes.
Cool. So we're talking about the active parents. Some really nice examples of this. It's one of these. We're naming this pattern, this active parent space key, and we're naming this active parent, this single case, called hold 100 milliseconds. Again, we're talking about real game code that is not actually, this we didn't put on the game. I put on a little game jam game that I've done. Basically, what you want to do is to either, the way in most platforming games you have a jump and a double jump, so you jump for a little bit longer. So in here, you're combining those two. And if anybody comes and reads line 7 to 9, you can totally tell, oh, okay, in the second case, you're saying the space key is true and you're holding for over 100 milliseconds, then it's going to do the double jump. If you write this in a, if and else, it's going to be slightly more convoluted. So I'm not saying that it's, rocket science, but it is, again, always about incremental improvement. At least it is for me. You can also do smarter things and do multi-case active pattern. In this case, what is happening is that the duality app.keyboard, it returns a type called keyboard input. I know it's a little bit confusing, but that's why I put the name there, the type name, also because otherwise it doesn't compile. When you do this match, the compiler goes and searches for an active pattern that will have this type, and it will match against this. So, I think it's a valuable example of multi-case. So we're doing this, which is kind of cool. So then you might be wondering, right, this is on the .NET platform. What about interrupt? Sometimes people tell you, yeah, it interrupts just fine. And then you go and do it, and it's a nightmare. Like, for example, when you have to compile a C library from 1983 in 64-bit, and it turns out that there's half of the dependencies of that are missing. This is a true story. So, when interrupt works for real, it's actually quite nice. So how does it work? If we're on the C# side of things, if we want to consume F# code from C#, it's very easy. You have two projects. Again, if you are not in the .NET platform and it sounds like I'm sort of crazy, please ask me. I assume that you understand what I'm talking about, but maybe if you're on Ruby or something, this doesn't make any sense. I don't know. It's just because I don't know how Ruby projects are structured. So, sorry. I just don't want to offend people by mistake. I don't know. So anyway, you can have two projects, one with C# stuff, one with F# stuff, and you can say that C# project will depend on the F# project, and then you just call, this is calculator, which is the name of this namespace. So you're matching this to this. You're saying this modulus dog, and you add, this method is called add. And you can basically just do stuff. Very simple. You could just say, it's nearly like calling C# code. That's because it kind of could be. It compiles to the same bytecode, so it kind of is. When you're consuming C# code from F#, you have the same thing. In here, we're running a test because the test framework is in C#. So we're saying, hey, this works. As I said, it really, truly just works. So at the moment, F# has a really nice REPL that comes for free in Visual Studio, and you can even include it in Sublime REPL and do all that kind of stuff. It's there. You can do stuff like let 2 + 2 + 4, probably. Oh, okay. Sorry, I did something stupid. Good. Maybe it's 4, please, be 4? Cool. So, it's like you can do this kind of live interaction with your code. Why would you need this in your project? Where, we're using an engine, and the engine has a very big surface API. Sometimes you need to check something soon, and actually running the game is time-consuming, at least a little bit slower than just running something in there. You can do this cool thing when you have something. You can right-click, and it will send reference to F# Interactive, so you can easily just use everything from there, which is nice. So, we were talking about tools, and we were talking about tools that we use now. Who's familiar with QuickCheck or FSCheck? Awesome. For those of you that are not, this will be like, wow. I hope this changes your world and blows your mind like it did mine. So what FSCheck does is generate your tests for you. Who likes maintaining tests? Exactly. See what I mean? It was a good question because all of you either are sleeping or you hate writing tests that are really boring, right? So what FSCheck does for you is you give it a property, and if the property is true, then it will tell you, hey, I tried this with 100 random values, and it worked. So you might be thinking, okay, what's a property? And the property is something like this. You're saying something, you're trying to prove something. So think back to math stuff, maybe. I did when I was looking at this, I was like, oh, okay. So you're saying x plus x equals 2x's. And that is true for integers, that is true for floats, all numerical types. Is this true for strings? I don't think so. Actually, that too might actually just constrain it to be an int, right? I don't know. So how is this FSCheck going to work? But anyway, we'll just focus on what a property, right? What's a property? So if you have a collection, a list, for example, the reverse of a list will likely be the original list, right? And instead of this uncertainty you have, you will be able to prove this with code that someone else generates for you. So, that makes sense?
Yes.
Cool. Okay, someone is awake. That's a test. I'll keep asking and see. So QuickCheck actually started in about 2000, 2002. I think the original paper is by these two guys, Klassen and Hughes. If you want to know more about it, you can. There's a few articles on F# for fun and profit. If you're in C# or VB, you can use this from those languages if you want. It's a very small library. So there was something called PEX in the .NET side of the world, and that's really good, but it's a bit heavy. It's hard to run on CI. This just works because it can use NUnit or XUnit, or it can run on its own. And the integrations for both are pretty good. So, how does it look? Instead of writing your test as test, public void, name of the test, and your test case and assert, you write your property. So you set up whatever it is that you need to set up. Whatever you want generated, it will be passed as a parameter, and then you verify that. And FSCheck will go and generate hundreds of values. By default, it will generate 100 values, and it will tell you if everything is okay. If it goes wrong, this is the coolest part of them all. If it does go wrong, it does a shrinkage process. That means that it finds the simplest possible case for the failure. I mean, just think about that. So instead of giving you, I just tried 1,000,000 against 3, and you're like, okay, but what does that mean? But if it's like, negative numbers actually don't work. Okay. So if it's -1, it's probably all negative numbers. So it gives you, when you find a bug with FSCheck, it gives you a place to start on what you did wrong, which is every time. FSCheck is, every time you write an FSCheck test, you find that at least 3 bugs. This has been my experience. I write 3 tests, 9 bugs, potential bugs that could have happened that I never thought about. It's really, really amazing. Okay. wondering, okay, this sounds kind of like a bit hardcore for a game, you know? I mean, aren't games supposed to be easy and, you know, chaotic? I'll tell you a secret. It's not a secret. Creative work is incredibly chaotic. I mean, it's absolute chaos. Working with a game is basically, you think you're going to go and build this nice thing with a dragon in it, and there's going to be this guy that jumps and breaks the dragon head, and it's going to be amazing. But you have, or it's like, hey, we need to finish that dragon scene tomorrow, and so you actually have just until tomorrow. The side effect of that mess is that first, whatever you had in mind generally changes every time. So all your nice plans for organized software goes to somewhere. So what you have to do with any systems for games, I found, is you have to make them easy to change. Whatever really, really needs to hold, you make sure it's like hard somewhere, like a test. Whatever doesn't need to be changed, you need to get rid of it quickly. I found that FSCheck is a great tool for that, because you can do something like this example. So, this health component is very simple. Again, you're Mario or some sort of platforming character, or you can be Jiro from this awesome game called Onikira. And, you know, it turns out that when you get health back, you can get health a little bit. There's some multipliers that are a bit strange. It could be that if a guy hits you, you lose more, and then when you get more health, it works in a weird way. It's actually kind of a weird system. What I definitely want to know is that you never, ever get more health than the maximum health you can ever get, because that will unbalance the game, or someone can try to do cheats for the game. So I wrote a property, and this little method goes and creates an instance of a health component. We assign a max health that is generated by FSCheck. And we're saying you can increase health by, again, a number generated by FSCheck. In this line, number 8, nobody saw The Simpsons? Okay, there's a Simpsons episode when Homer is hanging out with Yoko Ono, and he says, number 8, and he burps. It's number 8. It's really funny. When I said that, I really thought someone was going to do that. So anyway, sorry. So in here, you were trying to say, we're increasing the health, we're setting the max health, and this is a precondition FSCheck will abide to. So basically, we're saying that max health will always be bigger than 0. So what FSCheck will do is, it will generate, say for example, it will generate 0 and 3. And because the precondition is met, it will try to assert on the property. But if you put 58 and minus 2, it will get here and just discard that value. So not only, you know, you have all this extra stuff that comes with FSCheck, like this thing, that allows you to do really, really kind of a breadth of test of the system by just a few lines of code, which I think is pretty good. And this is, I'm showing here the test runner when it discards the value, when it's 0 or minus 19 or minus 34, and then it's 5. So when it's 5, it moves. See, this is the run number, 55. And then when it's finally a valid number, it turns to 56, which is what you would expect. I think this is amazing. I mean, you should all be like, wow, you just changed my life. I know maybe it's a thing that you're just not showing it. You're shy. It's okay. I believe you.
You already know it.
No way. No, I mean, yeah, of course. Did you all know about this? Is it useful?
Yes.
Okay, thank you. You stroked my...
Is there a possibility that your tests would become non-deterministic? Then, like, it might generate values for one test run and happen to break, but another test run, they don't, and then you get random errors.
Okay, so it's like, you're basically talking about, it's like, you're saying, because they're randomly generated, you could have like crazy values, basically. You know, I thought that would happen. I think there's I don't have a good answer to that. It hasn't happened in a way that it has affected me. Yes?
Does it generate values once or every time you run tests?
Every time you run tests. It uses a random generator. Yes?
Actually,
Wait, one at a time, he was first. Sorry.
The quick check in Haskell actually checks your cases.
Okay.
And because you can't create any kind of if statement or something like that, if there is a bug that you can have, it's based on the logic that is wrong. Not that you will create a kind of state that will create an exception, especially in Haskell. I don't know how it works in F#, but probably compiler also checks the cases in pattern matching.
But in this case, this is a different kind of error. It's like, it's not that the health of all these arbitrary marks will crash the game. It's just that it's undesired, but it's undesired from the point of the designer.
Yeah, the thing is, like, if you're doing a property that's just ill-defined, that's kind of your fault. But
another thing about this random error, so if it crashed once, then you got the information that there exists an input for which it can crash. So if you are paying attention to your CI, you will just correct it.
yeah, also, well, I think if you get one of those edge cases scenario, you probably, and you want to make sure that doesn't happen, then you can always just create a unit test or an integration test that covers that specific set of cases, and happy days. By the way, fscheck, when you're using it, it doesn't mean that you suddenly replace your whole test suite to be just property testing, but it means that you kind of have way less tests of the repetitive kind that you would normally have before you use property testing. At least, again, that's what I found. Another awesome tool that we use is a build tool called Fake, as a F# make. And if you like make or Ant, if that's good for you. What Fake gives you is types on top of that, and a very, very nice TSL that is proven for over 4 years. So that means you can have a nice build system for your .NET projects that works cross-platform, and that you don't really need to know F# to use it, but if you're learning F#, it can be a good way to add F# to your work. You know, nobody's going to say, hey, I really am dying to write the build tool. It's very rare. I've never seen that, except maybe me, but I'm kind of sad that way. It's true. Fake is really cool. It's used in a bunch of open source projects. The good thing is, because they're open source, you can see their example scripts, and you get IntelliSense and everything from Visual Studio. And you can go see in GitHub how they use it. You can build your solutions. You can run unit tests. You can deploy NuGet packages. You can zip whatever your assemblies are doing, and that's pretty cool. What it does is you create a bunch of targets, and once you are, basically you define the targets, and then you order which ways you want to run them. In this case, you have foo and bar, and you're saying bar, foo. So basically, foo will run first, and then bar, and if you have other stuff. Another effect of that is that you can comment out something out of that, and just run the target that you're testing. So it's a very iterative process. So that's very nice. Again, if you've ever done builds before, this is not common. This is not necessarily the case. And testing builds is generally slow because you kind of go like, okay, I have to test the whole thing, and that's not fun. So that's Fake. There is tools for building in every language. I think this one is particularly good. So, we're getting to compiler services. So, I remember I was showing you there that in our game, we have the scripts, and they run. So, compiler services is this cool library that one of the things that it does is you can host a compiler. So, this is an open source project as well. So hosting the compiler is probably the simplest thing you can do, and we're doing that. But you can also host an interactive session grab the AST and do crazy things, get all the information from your project and do a project analysis and a bunch of other stuff that is super cool. The good thing is, like, if you go here to compiler services and just click on one of these things like that one, it gives you sample code and how to run it, and it's a few lines of code for anything you want to do. So totally worth it. So what I'm going to show you here is the way the compiler services works for us is we have the game engine has a file watcher in a particular directory, and when there is a change to that, the engine kind of goes like, "Oh, I should do something." So it grabs this new file or the change file, it compiles it with compiler services, and it creates an assembly, puts it in another special directory, and the game engine goes like, "Whoa, new stuff," load it into the app domain, and basically it becomes immediately available to the engine, which is cool, right? That's cool. So that means that you don't have to recompile the whole game just to do a scripting change, which is cool. So instead of talking about stuff, because talking is boring, right? We're gonna do something. So I created a scene here.
Let's play.
What?
Let's play game.
Yeah, you can come play if you're bored, like it's here. So in here we have an F# script called Lambda days because that's where we are. And if we go here to the code, I have it kind of ready because I thought, hey, you know what? Maybe better that way. So what we're doing here is if we don't find this game object, remember we're doing par matching, it's going to print on the log, otherwise it's going to turn this on. But what I'm going to do is change this now so that it doesn't find it. So,
Can I have a question?
yeah?
What does assembly cheats do?
Oh, well, I can't tell you that. It actually, when you're testing the game, you need to actually play the game fast, so you need to have all the health and damage the enemies just to, but we don't ship that, so don't worry.
If I get this early edition of your game,
It won't be there. We have a good build process because we use fake and we remove all the stuff that doesn't need to be there. So in here, right? We have the game engine here, and I know you probably can't see it, but in here, once I change that, it pushed this assembly loader fs blah 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 blah. That means that if there's a problem, I can go and find it. So, and that happened just there, 1539:36. So when I do this, nothing's going to happen. We're saying hello Lambda days, so it didn't find it. So hello Lambda days. Yeah, good. Just, I should have done that. So if we change this so it finds it. So in here we're saying in the current scene, find the game object called new logo, and it could be non-active. So in here we have a new logo at game object, and it has a sprite renderer and our stuff, and it's not active. So if we do that, hello, come back. Sorry, apparently I don't know how to change the correct project. This hasn't compiled, or did it? Okay, let's try it. Just. Okay, so there it is. See, I was waiting for that to pop in, and now it shows, hey, Onikira. So all the script did is say, if it finds it, turn it on, and it's active to true. This is a mutable thing, so because we're dealing with C#. So it's imagine the feedback loop on doing this is quite fast. No compiling forever. Generally, you write a little bit more code than active true, but this kind of proves the point on how fast the iteration is. Okay, that was in case stuff doesn't work, because if you're showing it to people, it always breaks. Any other time, it's just great. So, any questions about the compiler services? Cool. I assume that's no, but yes.
How does it differ from having a little script that will just build an application inside?
Well, the problem is that when you... No, the problem is duality. When it has if the way you build that, it basically will restart the editor. Restarting the editor takes about 5 or 6 seconds, you don't want to do that because you don't have that flow. This is like maybe 1 second compared to restarting the whole editor, or maybe it loses some focus that you had or whatever.
So what you named hosting compiler services is like inside duality?
Yes. Well, one of the plugins, so the architecture of it is that in this, in here in the game, there is a directory called plugins, and one of them is called scripting plugin, and that is what hosts the F# compiler services. So, yes, so, now that all of you want to learn F#, obviously, you might wonder why, where. So you can go to any of those. They are really good resources, and if you're already very, very using C# a lot, or Java, or whatever object-oriented language you use, F# for Fun and Profit is really good at kind of onboarding people onto that, onto F# or functional programming in general, actually. If you like doing stuff as opposed to reading stuff, Community for F# has a bunch of dojos that you can follow. They can be about machine learning, about compiler services. There's just doing F#, and it's really cool. F#.org. You have also tryF#.org. You can do it in your machine, which is nice. If you're more of the book type, I really like this particular 2 books. There's more books, but this is the ones I like. And if you like attending conferences, you can go to London in the 17th of April. That will be a whole day of F#. And then, otherwise, you can go to Ncraftest in Paris. You might have noticed I like cats, maybe. And so we have a group called Functional Cats, and we do it's a cross-functional programming user group. We learn loads by actually doing extra inter-user group stuff. And basically, that's all that I have to share with you. Thank you.
And still we have some time for more questions.
So usually when people compare functional languages with the imperative ones, they complain about the performance. Game dev is known for the very, very high performance requirements.
Mm-hmm.
I mean, do you need just profile it and sometimes start using imperative type of programming in F#? Do you switch to C++ or C#?
Okay.
Or you just don't care and it's fast enough?
I don't care. No. That's a really good question, and I probably should say that in the talk. So performance in the way the performance analysis in this type of project, which is long-lived and whatever, is basically you get to a full feature set of some sort, and then you start making it ugly, basically. Which you always have this either pretty and slow, and the opposite. So far we've found that because we're using F#, the shipped part of the product that has F# is actually maybe 10% or maybe even less. So we don't have such a big impact. But even when the bits that you do, because it's scripting, we're not really creating such a mass overhead. It hasn't been so bad so far. When we hit the point where it is, we'll have to deal with it. But yeah, I am kind of concerned when the plan for us is to build some sort of wrapper around duality, so that it allows you to do either FRP or at least a nicer FP instead of checking for nulls all the time and that kind of stuff. So we'll see what happens then.
Because sometimes changing it to ugly, right, and making it more performant causes us to change it to mutable in some cases. So we increase the number of allocations, but then the immutability goes out of the window, and then we need to care about stage
as you see, we are not really being mutable. What I'm trying to show in this talk is that you have steps. This is the steps we're going through to go from a fully object-oriented C# only shop or whatever to, hey, these are the steps that we've taken and that have worked so far, which is I think it's a nice story to hear, because it's, it's been hard to know how to go about it, so it's not perfect, but there is a path. I think you can write pretty performance F# too. And in some cases, that there's this guy called Jack Pappas who writes about F# performance, and he actually achieved slightly better performance on some stuff on F#, just because he's really good at it. He's a performance junkie. So if you want to read about it, he's the guy to check out. Any other questions?
Can you do double jump?
I think so, yeah. Yeah.
Woo! Is there a sound?
Yeah, I just turned
Can you
it.
play it in the gaming zone?
Yeah, sure. Yeah, you can also play it here. I kind of thought it would look good, because...
Does it work on Linux?
No, but if you want to pay us 10 grand for us to port it, no problem. It's funny, we want to go to I'm not even...
10 grand zloty or?
No, 10 grand, which is the most expensive?
Pounds.
Okay, pounds. The thing's like, the problem with going, like, we're a small company with 6 people, and, porting is very expensive from a resort, time, and time is not free, and bugs, Linux support.
Why porting would cost so much if it's supposed to be cross-platform now?
Well, the languages and the libraries we're using are, but that doesn't mean that, for example, content doesn't just work. And like you have.
What's the bottleneck actually now that like libraries cross-platform and languages? What's the bottleneck for processing from that?
Well, when people say Mono and .NET are the same, they're generally like you can't just grab the project and it will build. It's very strange that happens because there's bugs in Mono. There's certain things that are done different.
This is going to change because now they merge both.
Great. When that is true, that would be great. It's just not. That's not. Maybe some paths are not using. Cross-platform paths. Like there's all these little things that you just have to go do it, and when you do it, you find out how you screwed up.
Okay,
thank you.
Again.